Hello. So as promised, I have an answer key that I'm going to put up for you here in the form of a screencast so that you can follow along with me, and so that if you don't understand something, this can be your way of reviewing, keeping in mind that we have a test on Thursday on everything that we've done with functions so far. So this pages 40 and 41 is a great review of everything that you're going to be expected to know. So if we start with A, f of x equals 2x minus 10, well, let's take a step back and read the directions. It says use the table option on your calculator to determine each of the following. Okay, so what you're going to do is you're going to type into y equals, you'll hit y equals, and then next to y1, you'll enter 2 times x minus 10. And then you're going to go to your table, which you get from second graph. So it's the y equals button to type in your formula, and then to get values from your table, it is second graph. The y equals button and the graph button are along the top row right under the graphing window screen. All right, so f of 3, this is an x value. So you are going to look into your calculator to see what y is when x is 3. And when x is 3, it says in the y1 column, negative 4. When the x column is negative 5, the y1 column says negative 20. So when x is 3, y is negative 4. When x is negative 5, y is negative 20. This last example is not giving us an x value. The x value is missing. We need to find the x value that gives a y of 16. So you're going to look in your y1 column for the number 16 in the y column. And what do we end up getting for that? X equals x equals 13, I believe. Yep, 13. I wasn't using my calculator, I was using my head. So these are x, this is an x value. These answers here were y values. Okay, and then the same thing for g of x over here. I would just clear what you have in y1 and then type this. Remember to type a fraction. I think the best way is to get that little empty box in the numerator, empty box in the denominator, and the way we get that is by going to alpha y equals, so alpha, and then above it y equals, and then it's going to be choice 1, n over d, and then you would just type this x minus 7 in here, and the 2, in the denominator, and then go to your table. And when, again, now we've got an x value. When x is 15, what does your y1 column say? It should say 4. When x is negative 3, what should your y1 column say? Negative 5. And now this is different. It's asking you to find x when y is 5. So now we're still looking at that y1 column, and we're looking for where y1 is 5. And y1 is 5 when x is 17. Okay, now exercise 2, these were a little more complicated. Some of us are still struggling with this function within a function. And the directions here say, use the functions above to complete each of the following. So h of x equals 3 times f of x minus 6 is going to be h of 4 equals 3 times f of 4 minus 6. All right, and f of 4, they want us to use this function up here. So f of 4 is negative 2. So h of 4 is just 3 times negative 2 minus 6. All we're doing is evaluating the function inside, getting our answer, and using that. So then 3 times negative 2 minus 6 gives us negative 12. B is using h of 11. So h of 11 equals 4 times g of 11 plus 3. So first we just need to figure out what g of 11 is. So g of x is up here, and it was x minus 7 divided by 2, and that gives you 2. So since g of 11 equals 2, you just replace it with 2. And instead of doing 4 times g of 11 plus 3, you do 4 times 2 plus 3, which gives us 11. Okay, and one more. What's h of x if f of x, what is h of x if h of x equals f of x divided by 6? So we got to do h of 20, so we're going to do f of 20 divided by 6. So what's f of 20? Go back to your f function. F of 20 is 30. So h of 20 is 30 divided by 6, which equals 5. Okay, now we're looking at a graph, and we've spent a lot of time on this kind of stuff, so I'm going to go through this, answer these questions pretty quickly here. Zeros, what are the zeros of the function? The zeros are where it crosses the x-axis. That's here, 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 and here. So there are 4 zeros. That one's negative 3, 0. This one is 1, 0. This one is 5, 0. And then this one is 7, 0. So we could state that as x equals, and then name all those x values, negative 3, 1, 5, and 7. You could also name those points, negative 3, 0, 1, 0, 5, 0, 7, 0. Okay, the absolute minimum is the lowest point, and that's that point right here. And that is at negative 1, negative 4. Anytime you name a point, make sure you put it in parentheses. But we compare that to the relative minimum, which is just another low point, a turning point. That's a minimum, and that would be right here. It's not the lowest, but it is a low point for its interval over there. 1, 2, 3, 4, 5, 6, negative 1. And I lied. Notice B is wrong. This is 6, negative 1. B is actually negative 1, negative 4. Okay, state an interval where it is increasing. Okay, so we are increasing in 2 places here, it looks like to me, from this point to this point, and from this point to this point. And remember, so I'm going to write down both possible answers. Remember, increasing, we're looking at the x values where it's increasing. I don't want to know where it goes from low point to high point. I want to know, I don't want to know the y values. I want to know the x values. When is it happening? So it starts increasing here at negative 1 and stops increasing here when x is 3. So we would say negative 1 is less than x is less than 3. All right, we're also increasing here from this point to here where our graph ends at this point, and this is 6, and this x value is 8. So it's also increasing over the x values of 6 is less than x is less than 8.